Hi, it's Peyton again. Time for round 2 for solving systems of equations using tables. We're going to move now from linear systems to nonlinear systems of equations. In here we're going to have one equation that's a line, and we're going to have another equation that's a quadratic. Let's do a quick little review of what a quadratic function is, and it has that distinctive U shape, either opening up or opening down. If you want to, you can think of it as a smiling face or a frowning face. It's up to you. Now, there are 3 possible solutions with these systems of equations. The first one is there are no solutions, and here's a graph for you. And this occurs when the line does not intersect the quadratic function. It doesn't come close, it doesn't touch it. It may come close, but there's no touching. The second possibility is there's one solution, and this occurs when the line is tangent to the quadratic. And when I say tangent, it touches it at only one point. And here's an example of that for you. And it's hard to tell, but it looks like they touch each other at when x equals -2. It's tangent, okay? The third option is there are 2 solutions. This is when the line intersects the quadratic at 2 points, and here's an example of that. Looking at it, we see that our quadratic opens down, and that our line runs across and hits one side of the U, and then continues its path and hits the other side of the U. Okay? Now, to find the solutions, we're going to use the same method that was shown before. We're going to input the equations to our calculator. We're going to look at a graph to get an idea, and then we're going to go look at a table of values. Okay? Here's our first example. And we have 2 equations. The first equation is a linear function, and it's given as y is equal to 1/2 x minus 5. And the second equation is a quadratic equation. It's given as y is equal to x squared plus 2x minus 15. Fortunately, both of these are in y equals form, so we can just put them into our calculator. And I'm going to put the linear function in first. And so it's going to be parentheses, remember that, 1/2, close our parentheses, times x minus 5. Okay? And then for our quadratic equation, it will be x squared plus 2x minus 15. Okay? So here's the graph. Now let's look at where these intersections occur. I'm going to deal with the intersection on the left hand of the y-axis, and it looks to occur when x is equal to -4. And then for the intersection on the right hand of the y-axis, it seems to occur somewhere between x equals 2, x equals 3. We really can't tell. So now let's go look at the table of values to find these intersections. So I'm going to push second graph to pull up my table. I'm going to scroll to where x is equal to -4, and lo and behold, the 2 equations are equal to each other. So the point of intersection is x equals -4, y equals -7. Now let's go look for our other intersection. And I'm going to scroll down to where x equals 2 or 3. And looking there, I can't really tell that an intersection occurs, but from the graph I know that an intersection does occur at that point. And I'm going to show you a way to find this. We have to play with the table of values a little bit. First thing we're going to do is I'm going to push second up here. And then I want you to push the window button, which should be right under your calculator screen. Okay? Now you should have your screen should pop up and it should say table setup across the top. It should have, the next line should be TBL start equals some number. And then after that you're going to have a little triangle and then capital TBL. What we want to do is we want to change the number that's next to that triangle TBL, and I'm going to change it to 1/4 or 2.5, or excuse me, 0.25. Okay, I'm going to do that, and I'm going to also change the table start so I know where to look, and I'm going to change table start, the TBL start, to 3. Okay, now push second graph again to get back to our table, and I'm just going to scroll through the values between 2 and 3. And it looks like when x equals 2.5 that the 2 equations are equal. So the point of intersection here will be 2.5, -3.75, x equals 2.5, y equals -3.75. Okay? Now we need to go back and change that table thing that we played with, so let's do that one more time. I'm going to push second window. The screen will pop up. Table start is across the top. Next to that is TBL start, and then the little triangle and TBL. I want to change the little triangle TBL value to 1. Okay? And you can change table start to 0 if you want to. Okay? Here's our next example. We want to find the solutions. One equation is given as y is equal to x squared plus x minus 6. And the second equation is y equals 7x minus 15. And these are both in y equals, so they can easily plug these into our calculator. I'm going to do the quadratic first this time. And so it's going to be x squared plus x. Ooh, push something on my calculator. It's going to be x squared plus 6, or excuse me, x squared plus x minus 6. And then our second equation will be the linear equation, and it's going to be 7x minus 15. And this is the screen you should have after inputting those. All right. Now let's look at the graph. And the calculator wants to think again. And oh, it looks like they're tangent at some point. Really can't tell. Let me give you a blown up version of my graph in a particular point. And looking at this, it looks like they're tangent about when x equals 3. So let's go to our table of values now by pushing second table. And we're going to scroll down to where x equals 3. And looking at the screen, we can tell that the two equations are equal to each other. So our solution is the coordinate point 3, 6. Okay? One more example. We're given the equation y equals x squared minus 4x plus 9. And our linear function is y is equal to 2x minus 1. I trust you can put these in your calculator, and I'm going to do that right now. And 2x. And we're going to take a look at the graph. Calculator wants to think again. And looking at the graph, it seems that there's no point of intersection. They don't seem to hit each other. And we can go and check our table of values if you want to, and you can scroll and scroll and scroll and scroll and scroll, and they will never be equivalent to each other because the two equations, just don't touch each other. Let's do a quick review of the method of how to solve these problems. The first thing we'll do is we will make sure that the equations are in y equals form and then plug them into our calculator. The second step will be we're going to look at the graph to get an idea of where the intersections occur. And our third step will be to scroll through and find these intersections. We may have to play with our little table of values like I showed you earlier, but it's not hard. And that wraps us up. I'll catch y'all next time.